Hello students, let's welcome to your chemistry class. So in this video, today we are going to discuss about the valency in detail. So you have already know that valency is the combining capacity of an element. Generally, all elements want to achieve 8 electrons in its outermost shell, that is called your octet. Valency depends the number of electrons in the outermost shell. So you can see out of this three picture, first one it has valency 3, second one valency 2 and third one has valency 4. So valency varies from 0 to 4. That means all elements have their valency from 0 to 4. Not a single element have valency more than 4. Let's see the electron configuration of first 20 element and their valency also. So we'll take the example of magnesium. The electron configuration of magnesium is your 282 and the valency is 2. So in case of magnesium, M is the valence shell. So you know 4 cells are there, that is your K, L, M, N. So in magnesium, in the K cell, 2 electrons are there, in L cell, 8 electrons are there, and M cell, 2 electrons are there. So what is valence shell? The outermost shell is known as your valence shell, and the electrons present in the outermost shell is called your valence electron. So to attain its octet, it has two options. It can gain 6 electron or it can lose 2 electron to complete its octet. So which one is easier? Is it easier to gain 6 electrons to complete its octet, or it is easier to lose 2 electrons to complete the L cell or to complete the octet? So if magnesium can gain 6 electrons, the M cell can complete, and if magnesium can lose 2 electrons, its L cell will remain complete. So it is easier to lose 2 electrons. Okay, so here are the then so now we understood that what is valency. Here we came to conclusion that the number of electrons an atom has to lose to achieve the stable electron configuration. This is the definition of your valency. Here are some elements which lose electrons to achieve stable octet. So one is your sodium, magnesium, aluminum, potassium, calcium. So you can see the outermost electrons what are there. 1 in case of sodium, 1 is there, in case of magnesium 1, in case of aluminum 3 is there, and potassium also 1 there, and in calcium also 2 it is there. So it is easier to lose one electron or 2 electron from their outermost shell according to their valence is 1, 2 respectively. Okay, next take the another example of your chlorine. So chlorine has 17 electrons and the electronic configuration is 287. Okay, you can see. So it has also 4 cell, but in the 3 cells only the electrons are distributed. In K cell 2 electrons are there, in the L cell 8 electrons are there, and in M cell 7 electrons are there. So which one will be easier to chlorine? Is it is easier to lose 7 electrons, or it is easier to gain 1 electron. So if chlorine will lose 7 electrons, it is very hard for the chlorine. Means chlorine cannot handle to lose 7 electrons. So yes, it is obviously it is easier to gain 1 electron to complete its octet. Now in the M cell it is 8 electrons. So now we came to conclusion that another definition of a valence is the number of electrons an atom has to gain to achieve the stable electron configuration. So before we read that, valency means the atom has to lose to achieve the stable electron configuration. Here we read that valency means the atom has to gain to achieve the stable electron configuration. So now we can say that by combining both the definition, valency means the number of electrons an atom has to lose or gain to achieve the stable electronic configuration. So here are some elements, okay, which gain the electrons to complete its octet: nitrogen, oxygen, fluorine, phosphorus, sulfur and chlorine. So in nitrogen, in the outermost cell 5 electrons are there, so it is very tough to lose 5 electrons, so it can gain the 3 electrons. According to that, you can see in case of oxygen, fluorine, phosphorus, sulfur and chlorine, everywhere there is very hard to lose that much of electrons, so it is easier to gain 1 or 2 electrons to complete its octet. Let us take another example, that is your silicon. The electron configuration is 284. So here it is easier to gain 4 electrons or it is easier to lose 4 electrons. What silicon will do in case of 4 electrons? How does silicon complete its octet? Is there any way? Yes, silicon can complete its octet by sharing of electrons. So how do atoms share electrons? Let us take one example. Suppose you have the chemistry notes and your friend have physics notes. So you have both the notes and your friends also have both the notes. Both of you want both the notes. So what you can do here? You can share your notes so that you can get both the notes, both the subjects notes you can get. So you can share. Like that, atoms also share their electrons to complete its octet. So here are some elements which share their electrons, that is your carbon and silicon, because they have both 4 electrons in their outermost shell. So here the carbon and silicon neither lost any electron, neither gained any electron. In fact, the electrons are shared. So here we understood that silicon and carbon, they can share their electrons without losing any electron or without gaining any electrons. So in total we can say valency means to lose or gain or share. So at last the conclusion that valency can be defined as atoms can lose, gain or even share electrons to complete their valency. Okay. So I think you have understood today's class. In next video, we will understood more about valency. Okay, thank you.